So today we'll start off with our parallel lines, and of course that's the symbol that tells you that they're both parallel, with our transversal, which is the line that cuts across them or intersects them. So again, we want to find x. So when you find x, it's over here, and you may say, what do I know about these two angles? Are they alternate exteriors? They are, and if the two lines are parallel, then they are the same size. So x is 68 degrees. So if you want to give these a try, pause the video. Let's go see what you remember. Okay, so we're looking for x. Well, x is right beside this one, and they form, one of their edges over here is a straight line, which means from here to here, these two angles added together add up to 180 degrees. So all I got to do is take 180 and subtract 132, either with your little calculator or by hand. And of course you had to borrow to get that, and that one's a 7, and 3 from 7 is 4, so 48 degrees. Boom. All right, number 3. Here's my picture. Oh, look, I think those are my alternate interiors, aren't they? Are the two lines parallel? They are, so since they're parallel, these two angles are the same size, 132 degrees. There we go. Let's see, number 4. And I'm noticing the lines are parallel. Oh, but that didn't even matter on this one because these two lines, I don't even care about this line down here. It's just that one intersection. Those are vertical angles, and all vertical angles are equal. So these two angles are the same size. These two angles are the same size. So this one is 120 degrees. And if you're curious as to what the other two were, well, if this one's 120 and it's along the line, that means this one is 60 because these two add up to 180, right? Which means these two are the same. And so these two are the same, those two are the same. Vertical angles. All right, this one. First I thought, ooh, corresponding. Upper left, but this is not the upper left, is it? No, but this one is the same as this since they're parallel lines. This is also 120. So, do these two add up to 180? Yes, because they're along the line here, so this makes 180 degrees. So what's 180 minus 120? Yes, you're right, that's a 60-degree angle. All right, oh, I skipped one up here. This is number 6, I guess. Oh yeah, 6. There it is, there's number 6. So on number 6, again, I'm looking for x, and I see this, and I'm thinking, okay, well, this angle and this angle are alternate exteriors, and since the two lines are parallel, then these two are equal to each other. And I'm looking for the x that's inside here, so I need an equation to solve. So I can simply say this equals that. So there's the equal sign I just said. This equals that. Or you could have said that equals this. It doesn't matter which side, which thing you put on which side of the equal sign. But one side needs to have the 5x plus 20. Oh, did I do that right? No, that should be a plus, and I can't talk and write at the same time. So one side needs to have the 5x plus 20, and the other side needs to have the 70, and they were equal to each other. And then you just solve. Minus 20 on both sides. Whatever you do to one side, do to the other side. That gives me 5x is equal to 50. Divide by 5, and of course x is equal to 10. So x is 10. That's not the size of the angle, that's just what x is. And then 5 times 10 would be 50, and 50 plus 20 is 90, so that would make that angle 90 degrees. But that's not what we were looking for, but that was it. Is that right, 90? I'm looking at that math again. 5 times 10, 50, 70. Oh, wait, 70. Oh, yeah, because that's right, because they were equal to each other, alternate exterior. Yep, so that would give you 70. All right, number 7. We already knew the size of the angle. It was 70 degrees. Okay, this one. Lines are parallel. And I'm looking at this and thinking, well, they're not alternate exteriors, and they're also not corresponding, because correspondings would have been here and here, upper right, upper right. But since they're parallel, this one is the same as its corresponding down here, which means these two add up to what? Yes, they're supplementary. They add up to 180 degrees, so I can make that equation. This plus that. This plus that equals 180. So you just got to come up with whatever math that you can or whatever geometry you know to make an equation. Once you have the equation, we're solving for x. So subtract 80 on both sides, which of course means 5x is equal to 100. Divide by 5 on both sides, and x is equal to 20. There we go, there's my 20. Number 8, I think last one on here. Again, parallel lines. And these two angles are both corresponding angles, and so since the lines are parallel, they're equal to each other. So this equals that. This thing here is literally 110 degrees. So 7x plus 5 equals 110 degrees, right? Because this thing is literally 110 degrees. they're equal to each other because that's 110, this is 110. So this equals 110. Just go solve for x. Minus 5, minus 5. Oops, that's not very pretty. Minus 5, my paper's moving. I'll get back here in just a sec. 7x equals 105. So 110 minus 5 gives 105. Divide both sides by 7. When you get done doing that, see what you get. Because whatever you do to one side, you do to the other. My paper won't hold still, but there it is. So 105 divided by 7 is, drum roll, 15. There you go. That side's done. We'll do the solving on the solving systems of equations, but we're going to do a different method today. So you might want to watch the video on the first couple to see how we're doing it. Thanks.